building, for the past, I think, 3 months, I've been working on an IoT project, agriculture, integrating LLMs, machine learning, and just having all that context feeding into the LLMs to help farmers. So we actually submitted something of that sort to Google, but it was in form of a chatbot which is accessible by farmers via WhatsApp. So after whilst building this thing, I had the idea of if this solution can actually work for farmers where it's mostly crop disease detection and that, why can't we do it in the medical space? Because it's kind of similar to me. I'm not a doctor, but I think to me it was kind of similar because of the processes I was following. So basically it was more of doctors spending time researching and getting to know, researching on a problem, researching on, let's say you have a patient with a plethora of symptoms, some you don't understand, you don't know their medical history, or you have a bit of their medical history. So they'll find, there was a case where I had a friend of mine who was hit very badly on the lip. They took around, I think, 3 to 4 hours checking with other surgeons so that they do not mess up his face when they were doing the surgery thing. So the whole idea around that is that them not having to leave the patient just to go and verify the process and what they're supposed to do in certain different scenarios. So basically the idea is giving them their time back by utilizing RAGs and LLMs. So what are RAG systems? RAG systems is a technique where we go through a bunch of information, like we take documents, we can take, it's data from multiple sources as well. It can be data from our IoT devices, documents, our databases that we currently have in our running systems, and basically being able to embed that we are able to split the text, make it into chunks, and then translate all the text to a mathematical vector form that can be easily understood by computers. For example, the word dog can be represented in numbers in a vector form. So it makes it easy for computers to actually go and search through the vectors because there will be similarities in terms of the size of the vector, the shape of the vector, and all those kind of details. So basically that's what RAG systems are. They're more retrieving data based on similarities. Yeah. The importance of RAG in healthcare. So the importance of RAG in healthcare is because there's a lot of data that has been generated over these years in terms of research, medical journals, books from, when doctors go to school, I believe they go through a bunch of book diagnoses, it might be treatment and those things. But this information is spread across the internet. There are doctors which are in remote locations, which do not have access to this data in real time. So basically the importance of RAG system is where we're able to collect all this data, have it somewhere centrally, and our LLM being able to access this information and assist doctors in a natural kind of way in real time. So how do they work? So basically with how RAG systems work, it's more indexing, retrieval, and generation. But when we talk about indexing, data is taken from multiple sources and we index it. Most of the time we do it offline. I'll show you guys where we have an offline version of a vector database and we have an online version of a vector database. But the process goes, you load, you split, you embed, and you store. So when we are loading, it might be our PDF documents, it might be from a website. We can take, let's say, a website with a bunch of journals, articles on tuberculosis, malaria, whatever, and then we load the data, we split it. And when we split it, basically what we're doing is we're splitting it into smaller chunks, so these chunks can be spread across and our LLM will be able to access this information in smaller chunks of text, and then it will do whatever it does in the background to give us the full response. So yeah, I took this image from a tool I'm going to take you through called LangChain. So basically what happens is that you load your data from multiple sources, you split them into smaller chunks. The embedding part is where we then vectorize this text, and then we store it into our vector databases accordingly. And retrieval generation is whereby now when a user has a question, for example, I have a patient, height is 1.2 meters, their weight is 120 kgs, they're having a challenge with maybe their heart is like pains in the chest area, those kind of things. So the user will send a question to the RAG. What the RAG then does, it finds the most similar matches. So for example, I said chest pains, right? So when I've said chest pains, it will go into the vector database and look maybe for chest or for pains, right? Then based on that, it brings up the relevant chunks. And when it gets the relevant chunks, it then passes them to an LLM, and LLM creates a natural processed message, and it is outputted to the user. So LangChain. LangChain is a framework which is designed to help build applications that utilize large language models. It's growing quite quick, because I think it's quite a new framework, and many people are building, most applications you've interacted with out there, which are saying they are AI-powered AI apps. LangChain is at the back of it, because what LangChain does is that it comes in with reasoning generation, and also it's able to then access external tools, which I'll break down in a few minutes. And with LangChain, it comes with two key features that I'm willing to present in this one, which is chains and agents, where chains are more of a sequence of tasks that the LLM is supposed to do. And agents is more like an instance of LangChain where you can connect your LLM and your tools. There are things which we call tools, which are external functionalities that we add to our LLM. For example, let's say we had embedded a document about malaria, but then now the doctor has a tuberculosis problem. What then happens? Most of the time, the LLM will try to give us an answer, but chances are very high that answer is incorrect, because it just used whatever it was trained on to generate the answer. So what happens with tools in our chains, in our agents, is that, for example, I can connect it to GCP and then create what they call SEP API, where I'm able to then search through the internet via my LLM. So how this happens, it happens through chains and agents. So the chain and agent, like I had said, LangChain comes with reasoning capacity. It then gives it the capability to think what it has to do on its own, without you having to tell it or to engage with it every step of the way. So basically, it can go on the internet, come up with relevant information on relevant sites, which means we can trust it because you can actually pinpoint where to source this information on the internet. It might be those, I think NHS in the UK has got a big library of diseases, diagnostics, and I think also treatment. So there are multiple sites like that from governments out there and things like that. But you then realize with doctors in Africa, we don't have that kind of setup. It might be there, maybe I don't know of it, but just because I don't know of it, it means maybe no one is using it, because it must be online somewhere. So basically, I'll just take you through those pieces of code, and then I'll just do a small demo how we embed, how we load, split, embed, and store into a vector database. So basically what we need here, we just need LangChain and LangChain community. So LangChain community in this case is very important because LangChain community is more like a community of developers which are building tools which will be open source, but these tools will be very helpful in the LLM. For example, like I was saying, we are able to search the internet using tools like Google, but there are LLM-powered search engines now. I'm not sure if you've ever heard about Exa. So Exa is more like a search engine, Google search engine, but it is AI powered. It is powered by LLMs at the back. So most of the times it brings relevant information from all your Google. It's different to traditional searching where you have to go through the information yourself. It does the searching for you and brings back the response. So these kind of tools have already been built that integrate with external tools like Exa and Google. You'll find them under the LangChain community and the LangChain hub. So that's why we need LangChain. And we have what we call LangChain Chroma there. So LangChain Chroma is a vector database. And that's where we then, when we load our information, split it, embed it, we then store it on our LangChain Chroma database to be easily accessed by our LLMs. So in this case, I chose Google Gemini. It's usually, it's a multi-large language model. So why I chose it is because it can go through diagrams, it can analyze images and just text like the rest of the models that are out there. It's quite flexible in performance as well. So I'll use this. I wanted to use what they call Gamma. These are small large language models that were made by Google, but these models are I'll say the foundation of Gemini. So, but I want, because mostly in many use cases it's the medical industry would like it to be private. So if the LLMs run locally on your private servers, that would be very advantageous because we don't want our private information to be going to external sources. Right? So basically, this is how you can get started with using LLMs in your maybe notebooks or in your Python applications. You need the Google API key, and Google, like I was saying, LangChain is a bunch of tools that have already been built to integrate with a bunch of LLMs that we have out there. We have OpenAI tools, Google Gemini tools. There's just a plethora of tools. It's a matter of choosing the model that works for your use case, and yeah, just pick the library. Most of the time, if the model is out there, it will have a tool on LangChain to work with it. Right. So here I am demonstrating the loading part. We load our information. In this case, I just chose, this is an article on the WHO website about malaria. So I just thought of just loading one page of this article where the doctor was talking about problems of malaria in Africa, symptoms and treatments, possible treatments with malaria. So what happens here is that we then load the site. When we load the site here, I'm using Beautiful Soup to go catch specific classes in the HTML page. Then, all right, prompting. This is the simpler prompting, which is just a normal prompt. We saw it with Ms. Duck earlier on basic prompt, which is an overview prompt, which users don't see. It's at the back. Basically, we are defining what the LLM is supposed to do. And in this case, I'm just telling this LLM that it's a versatile doctor's aid who has a vast knowledge of clinical medicine diagnosis, patient problem, and yeah. So, which means all the time when someone sends a message or invokes an LLM, this prompt will be sent to the LLM all the time with all the prompts this prompt goes to the LLM. So it will always have the context. So it's more like we're building context for the LLM to know what's supposed to do, how it's supposed to do it as well. So basically, this is how the setup all works. So now, the interesting part where we then create what we call, I mentioned tools, where our LLMs are able to access a bunch of tools to do things. One of the tools, in this case, once we have loaded our embedded text into our vector database, we then create what we call a retrieval tool. A retrieval tool is a tool that does the searches that I was talking about based on similarity. If I send chest pains, it can go in my vector database, look for chest pains, bring back the chunks of data that are related to those words, and once it brings them, it's then added to the RAG so that the RAG has context of the tool. And when the RAG has context of the tool, it will make a decision if it has to use the retriever tool or just use its information that it has per se. So in this case, if you use a retrieval tool, your responses are very quick because it doesn't have to go through all the context it was trained on. Basically, it goes through the documents, more like chatting with your document, right, per se. The interesting part now with agents in the prompting, there's different types of prompts. There's human in loop prompt where you talk to the LLM, let's say you say, I wanna get a bus that goes to Joburg, per se, and then says, it won't say buses which are going to Joburg, here are 5 buses. With human in loop, it might say, where are you currently at, so that it can then think about the nearest station, then goes look for specific buses that are at that station that's close to me. So that's human in loop. Then we have what we call reactive agents. Reactive agents are agents which are able to go through a thought process without you giving it like 5 examples with probability of, with the confidence levels, like we saw earlier with Herod, where we had, where we had these LLMs just getting information, one prompt like this prompt I showed here. With this prompt, it's kind of different because when you tell it that I have a set of tools, and when you have a set of tools, they can be whatever it is, but I'll demonstrate. In this case, I've built, I think, 2 tools. One that does an internet search, there is one from the LangChain community that does, it's a calculator tool, and there is one that actually checks the real time. Like, as we all know, if you go onto an LLM, especially if you're running it offline and just say, what is the current time, you're probably going to get the wrong time because it doesn't know what the current time is because it was pre-trained before time. So now when you write a bunch of tools, you have to put them, let's say, in an array. In Python, they are mostly structured in an array. You give the LLM an array of tools, then it will then choose. But how does it do that? You can utilize this kind of prompts, and with these kind of prompts, what happens is that when a user passes a question to the LLM runs a thought, action, and observation. Those are 3 steps that it goes through. It asks itself, not the user. So this happens in the background. It asks itself, do I need to use a tool? If yes, action. It takes an action and says the action, then I tell it that the action to take should be one of the tools. So in my tools, all tools have got description of what they do. So because of the description which I put in the tool, it will actually be able, because it has this array of tools, to be able to go based on the description of the tool it will be able to pick the right tool. And if the answer is not, if it is not confident with the answer, it then comes to observation and observe the answer that was outputted by this action. Because this action picks a tool, this action generates a query to put into the tool. Then when that action outputs information, it observes. When it observes that information, it then decides if it is going to respond or go through that same process again. Because to some extent you might find this answer is correct, but there's another answer on top of that. So it goes through this loop until it comes to the right answer. And pretty interesting, it's quite interesting. It does this really fast that you don't even notice that it's going through all of these loops. And also, another cool thing with regs is that you can add memory to regs. I believe everybody who's been using ChatGPT-4, you've noticed how ChatGPT-4 now remembers, but back in like maybe 3 months ago or 4 months ago, it wouldn't remember what you were doing. So now, they added what we call memory into the agents or into the regs or into the LLM systems, right? So what happens with the memory is that in that case, it's more session memory. So you might create session IDs and store them somewhere so that this history is persisted over a long time. So for example, if the doctor had asked the chatbot to do something for them, and later they want to know what was the response on that thing they asked on it. It still remembers, so you can be like, hey, what were we doing yesterday? And based on this memory, but you'd have to store it on a database somewhere in like a SQL, NoSQL, whatever works for you. And usually, I think everybody who's working with maybe LLMs have seen these keywords like K. Mostly the K represents similarity, so how similar you want your output to be or your search. It's more like if it's 1, you want something that's very close to the words that you put into the LLM. If it's 2, you're saying I can open up my window for answers until you get to the right one. So this number, you usually just tweak around with it until you get to the right number. So this is more with the memory as well. We're handling your memory. You can have your memory as human message. So LangChain comes with these 2 cool functionalities where we're able to tell the AI message from the human message. So that helps us in storing our history, the memory of the message, because we know what the human said and what the AI said in that chat. So yeah, regs, I believe regs can do a lot in healthcare, as for example, like I was saying with tools, with the real-time data analysis, which means now we can build tools that can plot, that can visualize data. If we have data in our database, wherever, which means when you create a tool once, which actually knows how to generate, let's say, code to visualize, what can happen is that you can just ask it, can you just visualize my sales data, or can you visualize my, maybe, I'm not sure in health, my appointment times, how long it takes for us to do an appointment, those kind of things. It will easily visualize using these tools that you have attached to it. So basically, it automatically just does the thing for you, just like an assistant, just like how an assistant does. So now I'll do a small demo for a RAG agent. One of the key things I want to do with this demo is show you how we can be able to debug the processes at the back end, because for instance, when I was explaining, I'm explaining how this LangChain is able to think on its own, but then how we're able to then see what it's doing, how it does it, if it called the right tool, and because we want to know if it calls it in the right time or if we need to change anything on the app. So basically, I'll take you through, I have a bunch of documents, PDF documents. I'm not sure if this is legal, but I found a lot of books. I found a lot of books on On medical, these are more books from school which medical practitioners or people who are studying medicine use in their day-to-day. So I collected quite a few of these books so that I can embed them and store them into my vector database. So I'll just take you through, do this. All right, cool. So this is like half done. I thought I'll do a lot on this, but it's quite half done. So what happens here, I'll just take you through with what happens here. Basically, the idea here was more creating it's more of a platform where users can book appointments with doctors, right? And maybe that's me. Yeah, I'll just get started. All right. So I'm already a user. I'm already registered. So basically, there is a whole form about medical history that's supposed to come up where we check your medical history, your family history, and all this data is then stored as patient information. And a patient can then come into this platform, maybe set up an appointment with a doctor. And once an appointment has been made, the doctor is then able to then come see these appointments from, they're then able to come see these appointments on the admin side of things. So here I was supposed to do a whole lot of things where the LLM is supposed to then link up with all appointments, but I'm going just to do I'm going to demonstrate the RAG agent on its own, nothing complex. So that's my agent. So what I'm going to do here is I'm going to load up a document. That one I uploaded. So clinical medicine, a system of diagnosis in the outline. So what happens here is that I'll show you the code, and in this case, when I upload this document, what's happening here is that I am uploading the data, splitting it, embedding it, and storing it onto my vector. Maybe my internet, but I'll just take you through the vector database that I created earlier on from a document. So when I used Supabase as my vector store so that it's persistent. There's quite a few. I show there's LangGraph, not LangGraph. There's ChromaDB. There's FICE. But this database I do not like to use because they create like a vector store which is offline. So for you to update it, you have to create a new one. So I'd rather have your vectors go into a database because you just know that you've put this document, and maybe whoever is attached to, who's using the LLM and it's attached to the vector database, they'll always have access to this information, and the RAG will always have access to this information. So like I was saying with making chunks of data, as you can see, this data was, this is just text data that has been translated into a vector here. So that's the vector representation of this chunk of information. I'm not sure if at the pic you're able to see my mouse, but in this row, the first row, which is saying context, that's the text that was made into chunks. And when it was made into chunks, then translated, embedded into vectors. And I used a Google. So with making embeddings as well, there are a lot of tools. There's OpenAI embeddings. Also, when you're working with embeddings, there's sizes. Some tools do not allow. Like for example, Supabase only allows chunks with 768 characters. So I use Gemini embeddings tool, which does like 768, which is kind of low in this case, and it works. But what this means is that I have more chunks of information. For example, from let's say a 3,000 page document, I have a 1,000 page document, I have 100 rows, 32 pages of 100 rows. So those are all chunks, and my LLM has access to all of this information. So how we can try to check if actually our LLM knows about this document. So I'll just say hi. Yeah, so it says, hello, I'm Assistant Danny, a versatile doctor's aide with a bunch of knowledge in clinical medicine, diagnosis, Chinese medicine. How can I help you today? So I have a malaria patient. So with LLMs, we have two options. I'm sorry to hear that. What are the patient's symptoms? So mostly we have a problem with LLMs where they hallucinate. And the problem of hallucination comes into play because of how they are trained. Some are not trained on the information that we're looking for. So at times it is, but it just does its own thing. But when there's two solutions to that problem. It's either we fine-tune the model, which is quite expensive, or making a RAG, where we don't actually touch the model, but then we add more information as context to the model. So in this case, our vector database will be like context for this chatbot. So what I'll do here is I'll go to the document and look for something. For example, I'll say bedside manner and communication skills. Tell me about bedside manners. So then in this process, it's going through all those steps in my thought action prompting setup, right? Then now it's done. It took this information from our document, but how are we able to then trace and see if it actually took it from the document and not just hallucinate? That's where a tool which comes with LangChain comes into play. It's called Langsmith. So Langsmith is more you tracing your LLM calls and seeing how it's working, how long it's taking to doing the calls. So for example, this is my recent call. As you can see, this was my input. I said hi. The AI was like, hey there, I have a malaria patient. I'm sorry to hear that. Tell me about bedside. My spelling was even wrong there, but yeah, LLMs can figure that out. So what happens here, these are the steps the agent took to get to the answer that I got. For example, when I sent the message, it went straight onto my Gemini, into my Gemini LLM. And like I was saying, the tools I've attached to it are called Search Latest Knowledge, Get Current Date and Type, Calculator, and Search. Search is the internet, calculator, basic calculations. Get current date, it gets today's date, today's current time. And Search Latest Knowledge is the retrieval tool. That's the name of my retrieval tool. In this case, it's showing us that it called Search Latest Knowledge. So because I gave this name to my function, I actually know that's the retrieval tool. So it actually got the information it gave us from the document, not from its context or from the internet or elsewhere, but from this. So to some extent, we can trust this information coming from the LLM because it's information coming from a verified source to some extent. So as it goes through that chain of thought process, it goes back on our tools here. It goes search latest knowledge. This is basically its steps. Do you see? This is the chunks it got from our vector database. As you can see, it's not really an answer. It's just a bunch of text based on the matches that were done by the text I inputted into the LLM. So because of this text, it then, as you can see, says vector store retriever. and then basically it knows how to do it with the vector store retriever on its own, because it has a tool. LangChain has a tool which is called a vector store retriever, which you wrap up your function with. So it actually knows this is specifically a retriever tool. It's quite different with other tools. You just wrap them up with a tool keyword, but with the retriever, you actually have to wrap it up in a retriever to tell the LLM, like, first of all, this is where you check. So what happens in the process is that all the time it checks the vector store first before going to other tools. So when it comes to cost, let's say if you're using tools like Exa or Google for searching, the cost can become a little bit lower because it's not all the time you're using those resources to search the internet. So basically that's how it works on an overview. But this can also, with the tools, I'm not sure. All right, full Python. How do I increase my text here? It's enough. All right, so here, this is a brief code on how you make a vector data store. Basically, you get your PDF documents. From your PDF documents, you extract all the text in the PDF documents. You use the Google Generative embedding. They have an embedding model, which is, it's free. So also the other thing with Google Gemini, it's free for devs. You might, if you try use it as a normal user, they will ask you to pay for the pro. But if you sign up as a dev, you get access to the whole thing. So that's an advantage for now. I'm not sure how it will last, how long that will last, but yeah, for now. So in this case, the important part where we try not to lose context of the document is when we split our text into smaller chunks. So in this case, I have mentioned that my chunk size must be 1,000 characters and they must overlap by 800 characters. Why we put the overlap is that so that we do not lose context between one chunk and the next chunk. So we'd rather have an overlapping where we take even the maybe 5 fields from the previous chunk on this chunk so that there is context of joining of the chunks and things like that. Because most of the time when you search for something, the results are quite close together. So you don't want to lose some of that context. So that's why we do the chunk overlap. And the last part is generating our data store. And when we generate our data, so in this case, this vector database is a FICE database which was made by Facebook, where you can run this. It's like a file. Once you're done with generating the data store, you get like a file which is a .fice file, and you can easily import it and just, so it's more like a small file, but there is a lot of chunked data in it that can be accessed by our LLM. And the whole prompt, so that you guys see the whole prompt, this is my prompt for it to work. So basically I tell it a lot of things. So it is able, I tested this, but I wasn't as confident to demo it, but it manages appointments. When a doctor goes into it, asks, what's today's appointments? It can list up today's appointment based on that tool where we can get current time, where we can ask the bot what is the time and gives you the accurate time. So based on that, it can be able to go through all your data, your database with appointments and check which ones are for today or tomorrow or those kind of things. Or even send you alerts, maybe as a practitioner, to get alerts to say, yo, your next appointment is in the next 20 minutes, 25 minutes. It also has to do it for the client as well. So there's a lot of integrations that have to be done there for it to work smoothly. So basically this is when a human doctor patient asks for, so the other important thing when you're making your prompts, you must specify that this is human, this is you, the AI. So that's where most of the time when I'm talking about the user, it's referred to as human and it itself as AI. So it goes through the same. You also support doctor studying, revising, and all clinical scenarios. and then you give it access to the tools. I'll take you through some of the tools that I made, and it goes through the whole thought until it comes up with an answer. So in terms of tools, so I have a bunch of tools that I have here that I've created. For example, I'll just start with this one, quite interesting. So basically, like I was saying, when you make a tool, there is a keyword, a tool which comes with LangChain. So when you create your function, it already knows that this is a tool. It's not just a function, it's actually a tool which is supposed to be utilized by our LLM. So you then give it like a doc string where you specify how the tool is supposed to work, or even specify what's supposed to output. In this case, I've played around with it to an extent that when you put add more text in here to say, please output JSON, it can actually even format the output. Because in some cases, these tools are dependent on each other, where response from tool 1 is needed as input for tool 2 until the chatbot gets to a certain answer. So in this case, I had a simple SQL database where I was just finding the users. In this case, this use case was mostly for WhatsApp, where doctors and patients are able to access all this information via WhatsApp. So as the user when you chat with the system, if you're registered as a doctor on our system with that number, it's able to go and fetch the client and see who you are. And already when you're chatting with it, it's chatting with context of who you are, what you are, based on what we have on our system. So it's the same with appointments. It's just more writing your normal queries, normal functions, but the keyword is the tool thing and adding a doc string. And in this case, it just returns my appointments in a more like a JSON format. And when it gives it, so when this is returned, it is fed into the LLM, and the LLM goes through the thought process until it comes to a conclusion. And most interesting part, I like this part mostly, the search one, where we use AI to do the searches as well. So exo search, it's more like I'm having an LLM inside an LLM, because now what happens is that when all the tools fail, there is only one tool it relies on, the search tool, where it then goes through the internet to look for the most relevant answer and bring it back to you and maybe generate text, and hopefully it will be helpful to the doctor or the patient in that scenario. So in this case, we have like 3 types. I wanted to be more specific because in some cases, this search only brings like your search result. When you go on Google, you just say how to write Python, those 5 results you get, but there's not enough context on that block. So it can also decide that this is not enough information, but the blog is okay. Then it can get contents of what it found in that. So like I was saying, where tools depend on each other, in this case, all these 3 depend on each other based on what LangChain decides to do, or what LangChain feels like is the best tool to use. At times it might find it's search, but the search didn't give it the best answer, so it will take the search, put it into context to get a little bit more. Yeah. So then the simple one, so this one was more me fixing a bug, because I couldn't get the appointments or get it to schedule without it knowing the current time. So I then just got time, and so, but I'll then show you what happens in my tools. Process user input, this is me calling the LLM. So here, where all the magic then happens, where everything is threaded together, is I put get current time. So the positioning in the array also matters, because from my experience, I think it checks the right tool as well. It triggers the first tool even before thinking. So it can just choose the first one, even if it's the wrong one, then decide that no, this one has the incorrect answer and gives you, then goes to the next two. So in my case, I always wanted it to know the time first. So I started with getting the time. So whatever it is that I'll do following that, it knows the time, and I can be able to manage appointments for patients or for like our medical practitioners. And our prompt, the prompt that I just showed you here, this prompt, there's a whole, this one, it took me a lot to figure it out, but there is a templating system that they have in LangChain, where with this templating system, it is able to then communicate, you are able to then import the prompt as a template in this case. So now you then input whatever it is that you want in the template. For example, for the prompt to know about the tools must be passed to the prompt. So how you do that is you do it with your custom prompt template, where you define the template, you give it the tools and the input variables. And for the memory, conversation buffer window memory, so that it always knows what we're talking about. And you then create our agent, the React agent. So basically, we have agents you can import from LangChain, which is just a normal agent, but a normal agent doesn't actually go through that thought process thing that we're talking about. In this case, that's where the key part comes in, because a reactive agent is able to use the type of template or the type of prompt that I made. It understands it because there's a whole paper written around reactive agents, and yeah, it's quite a big paper around reactive agents and how they think and how they do the reasoning and get to the conclusion. So then in this case, this is a function where we take the user input, we pass the user input to the agent executor. This is our agent executor. This is where the LLM model is joined with our tools and our prompts, and then we get to invoke it. And when we invoke it, that's where we start the whole thinking process with our LLMs. We format the response and we bring back the rightful response. So yeah, I think that's more on LLMs and RAGs in healthcare and how they can help accelerate medical insights. Because yeah, if you have any questions.